Today we are going to see the advanced topics. So the title is Introduction to GIS. So briefly I will cover the topics. What is GIS? So Geographical Information System. So geography is location specific and information system is a system for storing the data, collecting the data, manipulating, retrieving, displaying, all those things. So it stands for Geographical Information System, GIS. So what are the things that you can do? So the thing is, already you are aware, the data you can represent as a point, as a line and as a polygon. So some of the features you can represent as a point, some you can represent as a line, linear feature, and another as a polygon. So these things are stored in various thematic layers. These things are stored in thematic layers. And if your requirement is there, you can merge all those things and it can be used for preparation of the maps. Okay, next. So geography related to the maps, information is the data and system. So all the things we are going to use in this digital mode. Next. So this is actually history of GIS, 1960 onwards, and now in 2025 they are there. It is already associated with the artificial intelligence. So we worked in 2002 also. This ArcGIS is earlier, it is in the DOS prompt. You have to do the comments. Where we can start it so black screen and then you have to do the comments. But after that, graphical user interface has come, which makes the life simple. You can see that all the icons are there and it is self-explanatory. We needed how to memorize all those comments. So it is user friendly, So what are the principles of GIS? So data capture, because data is the prime requirement. How you are getting the data from the maps, installation, or from the survey data, or you can get from the photographs, all those things. Data you are capturing. And the data capture is by remote sensing. Data management and update. So, how you are going to manage the data? The data is there, so you can retrieve the data, you can display the data, you can store, and whenever you are going to use, you can use the data, you can analyze the data. And geographical analysis. So, we are going for whether it is quantitative and qualitative, depending on your requirement. Quality. Then last, how you are going to display the results. That is very important. How you are the same data, after the results you can display in variety of fashions. For this I have one example. Suppose Dhanbad city is there. You have collected the population data, all those things. Then how you can able to classify that particular data? You have collected all information regarding the population. How many variety you can get the data and you can display the data. One is you can show the lower income, median income and the higher income. You can have one set of data, is it that? Then male, female, transgender. Then children, young people, middle age, then your senior citizens. Other classification, educated, non-educated, means illiterate, illiterate. Okay. So then depending on the work, it is private job, government job, or it is the entrepreneur, or it is like this. So many types, the same data you are extracting. Similarly, you have the point data, line data, and then your polygon data. Depending on your requirement, you can prepare different maps, different thematic maps, thematic layers, thematic maps. Theme wise, thematic means theme. The same area is there. You want soil map, means you will have only the soil features. If it is geological map, you will have only geological features. But if you see the topo sheet and satellite image, it contains all the things. You are extracting what it is required by you. Okay, next. What are the components? What are the components of GIS? So the components of GIS are the data is there, then software, then hardware is required, then the people. Okay. And see what are the methods? The data is important, the software, whether it is QGIS or GIS, how you are analyzing the data, hardware. Hardware means the system is required because software is there in the system, and what are the different methods which you are going to do? The raster analysis, vector analysis, and finally it is the people. Because end users are people now. After doing all the things, what you are going to do? You are going to get the results. Next. So, hardware, the GPS device, the hardware, scanner, computer, software means you have the GIS software, then QGIS, AutoGIS, RAS GIS, then data, spatial data and spatial data. This is very important. Spatial, non-spatial, or attribute data. What is the difference between these two? Suppose you have got an area, your number of bore wells are there, you have collected the samples. Suppose one location is there, I have collected the groundwater sample and I have analyzed the data. You know, for drinking, what are the things? Viscoparameter, everybody analysis. pH, alkalinity, fluoride, nitrate, sulfate, okay, sodium, magnesium, calcium, potassium, heavy metals, iron, arsenic, you have done. Then for each thing you can prepare a map. Is it done? So these are all there in the tabular form. Location, latitude, longitude, all is there. This is the background. That is attribute data or non-spatial data. Now I want to prepare a alternative map. What I will do? I will select the points, latitude, longitude. I will get the location. Then after that, what is the concentration? With the now three columns are there: latitude, longitude, and serial number, and then what is the concentration. And I will prepare a map. The map will be displayed. That is the spatial data. But how I will get that? By using the non-spatial or attribute data. These two have a connection. I think in lab you might have seen. If you select the parameters or if you select the components on the map, the attribute table can be highlighted. Or if you have highlighted or selected some of the features are in the attribute table, that will be highlighted in the spatial. Because both have got the relation. I think you might have seen the query also. Question. Query means questioning. I want some information. How many bore wells are there where the pH value is more than 8? That is the question. I will give pH greater than equal to 8. Okay. Then those things will be highlighted. So GIS is also used for querying also. Questioning. Google, it is very common. By knowingly, unknowingly, we are doing this. Is it not? We are traveling. First question, what is the distance from Dhanbad to Kolkata? Look at you. By land, by rail, by air, this much distance. That is what you are doing. You are questioning. Next. So, how the GIS components work? Data acquisition. I am acquainted with the data. Then data entry in the system. Next. Data management, data analysis using the software, and finally data visualization. These are all in the GIS components and this is the workflow. Yes. So, how will you get the data? See, there are various sources. You want to get the what is remote sensing? you want to get the information without contact. Earlier days, they used kites. Small camera will be tied to the kite and they will and then you will get the information. Then there are some spy pigeons also. Is it right? In age old days, kings they used that. Okay, some small birds, and you will have small instruments which are tied. It will fly and it will get the pictures. Okay. Then gas balloons. Then helicopter, aeroplane, photogrammetry. Have you heard the word photogrammetry? Okay, photogrammetry. Then finally, satellite images. So field survey is also there. If you are using total station, you are getting the information without intent. It is also a remote sensing, is it not? All these are data. And that one, it looks funny and very abnormal to you, but that is a floppy disk. In their case, we use it to store very less data in the floppy. After that, CD. Now it is gone. And then paper files. If you have a map, how I can get the map into the system? By scanning. You have A0 scanners around surveying. Okay. And the data you are going to use. So digitization from the paper maps, scanning, and GPS. If you carry the GPS, obviously what is the route that you have traversed, you are going to get next. So raster vector, this is what I want to, so that you can have the idea. What is a raster? What is a vector? The real world situation is there. Raster means it will be pixels, and then suppose you have a photograph. It is a raster. It is having the cells. Whereas vector means it will have coordinates. It will have coordinates. You want to, x-axis, y-axis is there. You want to point x1, y1. You can point to x1, y1, you have a dot. Then that is a vector. The line is there. x1, y1, x2, y2, x3, y3. You join that, it is a vector representing the line. Then for polygon, similarly, it is joining x1, y1, x2, y2, x3, y3, so on. Finally, you will come with x1, y1. So that is a polygon. So that is vector, and another one is a raster. Raster, you have the grids like that, and then vector, it will be like this. Just to have more clarity. So what are the advantages, disadvantages? So that is already covered. Just next. So this is the one. It is the reality. Raster, you can see, because it is the cells grids. So that road is represented like this. The road is represented like this. The road is represented like this. Whereas the vector, it is by coordinates. So, which is more realistic? Which is near? Which is near to reality? It is vector. Is it not? The raster we don't have this. Now see the real world situation. This is what real world. You have a home. There is a trees. There may be a water body. And then you also have a house. Big building. If it is a small building, you can go for a point also. So this one, in the vector, it is represented as a point, and these are set of trees. This polygon is represented, and then this is represented as a line. Point, line, and polygons. Whereas the same thing, here it is represented how? Because you have sensor, this one is there, and then here it is highlighted. Representing this. Okay, this is the river. Not that much realistic. And in some of the test books you can find the numbers also. 1, 1, 1, 1. This is 2, or this is 3 like that. But finally the moral of story is the sensor grids we are going to utilize, whereas there we have coordinates. That is the major difference. Yes, this is what I cover. Spatial data, raster and vector. Yes. Here it is a chain. See how realistic it is. Vector model is more representing more, whereas raster is like this. Yes, next, there are various formats of the raster data. This commonly we use JPEG file. TIFF, is it commonly we are going to use as next. The vector also you have got different files. You have created point, line and polygon shape file. Okay, then AutoCAD DXF, data extent, if you want to work in AutoCAD text. Yes, this is what I want to cover. Map projection. Actually, how the real world is? Real world is 3D, circular. But we are representing that 2D. 3D to 2D. In survey also, if it is a small area, you are taking it as a linear. But what is happening? If it is a bigger area and your project is very significant, you have to consider that curvature also. You have to consider that curvature diagrams. So here the 3D is there, you are representing now the 2D. How it is possible? Obviously some error will be there. Yes, next. How you are going to do that? So there are 4 important properties. The area of a body is there. The area of that, the shape, the size, the distance and direction. These 4 are very important. So area, shape, distance and direction. These 4 are very important. So if some body is there on the 3D, you want to convert it into 2D. You cannot maintain all the 4 at a time. If the area is important, you have to go for one projection. If the shape is to be retained, go for another. If the position is to be, then another. If the direction is important, suppose in navigation, the sailors are there. They doesn't want any body shape or size. They want the direction because ship can move. So their direction is important. So area you want to retain, then you have to go for that equal area conic method. If it is a shape, Mercator projection. You have different ground box in the resonance. Distance you want to maintain. Then you have got equidistant projection is there. Whereas direction you want to keep same for the 3D and 2D. Then azimuthal. You got the point. There are 4 things. The 4 cannot be kept same. You can concentrate on one. Direction is important. You keep the direction of the 3D and 2D same. The remaining may vary. So it is useful in air and sea navigation. Yes. Yes. What are the 3? What are the different types of projections? The first one is the cylindrical projection. A globe is there. Okay, you have a cylinder. You think that the cylinder is analytic the globe, and then you open that cylinder. You will get the projection. You will get the projection. This is the one. So you assume that the globe is within the cylinder, and then all the things will be superposed and we are stretching this. Conical projection, name itself tells. What it is? The entire globe is cone, and then we are again opening that cone. The third one is azimuthal projection. Planar. What we are going to do? A plane surface will be there, top and bottom, and it is fast. So we get this. Azimuthal projection. These are the various types of projections. Okay. So these things will be utilizing depending on the need. It is covered by Professor Sharma. Is it? Close this. Next. today we will discuss the spatial analysis. Terms not dated useful information. So what we can do with the spatial analysis? We can query, can ask the question, measurements, overlay, that is what I have shown in our previous case studies, one layer over other layer. In the landslides, Darjeeling I have shown 10 layers are overlaid. Then neighborhood operation. So a point is there which is very much near to that point, a neighborhood. Connectivity. So suppose an accident has occurred. What is the shortest route for nearby hospital? Connectivity. All those things can be done. Register operation. Next. So next. Previous. So these are the different types of ways which you can display the data. What is the first one? Solar radiation. What you can see? Only the red color variation is there from white to red. This is soil map where polygons are there. This is linear features are there here at the bottom, and then here it is a you have got the elevation also. Is it map? 3D. Next. 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 Here just overlay you can just see. Lithology map is there, which is nothing but your geological features. Then we have taluka map. So individual talukas are there in different colors. If you merge both the things, then what you are going to get? See this? The geological feature is also displayed, and also the taluka is also there. You can see both the things can be displayed here by overlaying these two. Next. 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 So these are various things that we can. Yes. This is one of the things, buffer I am telling you. Whenever a river is there, near to the river, you should not go for any construction. After some private days, Yamuna action plan, Ganga action plan is coming up in the rivers. Because why the flooding is occurring? Insufficient carrying capacity. The river is there, and you are constructing your structures very nearby. Whenever heavy rainfall occurs, flood will come, and then there is no way. So that's why inundation is going to happen. So what we can do is you can pass the rules. From the river to 50 meters, we can go for the tree plantation. From 50 meters to 100 meters, there are temporary structures. From 100 meters onwards, you can go for a small residential buildings like that. So there are different zones now. So that is displayed here. The river is there, less than 1 kilometer, then 1 to 2, 2 to 3. I have also given one of the example. A nuclear power plant is there, center. So within 50 kilometers, no major industry or structure. Within 2 kilometers, there should not be any settlements, because whenever any industry comes, obviously, who are the people who are working, they will have their own houses, is it not? So, and commercial activity will increase. But nuclear radiation, if there is any issue, then it will have the radiation effect. So, that's why you will have a circular, buffer there. Point buffer, then this is linear buffer. Similarly, you will have a polygon buffer also. The forest area is there, so no encroachment, wildlife, present forest is there. So there no industry from this forest area to 5 kilometers. You will have a buffer. You will have a buffer. Next. This is very important, all of you, please understand. I think this is covered. So this is the topic which I want to do, and already overlay analysis I have explained. How it is actually happening, that we will discuss. Please listen, and if you have any doubts, please. Boolean operation in raster GIS. Here you can see, actually this is a bigger one, but for understanding this is sufficient. You see the left one, this one, and this is another one. Is it right? Now, what cells are here or 7? Whether it is here or 7, that is my question. Now, 0 and 1, these are the two values that we are going to use. Yes or no? Yes or no? Means 1, yes is positive, no is 0. Is it not? It is not 0.5. Yes or positive value is 1, negative value is 0. Now, first one, this is there. What are the cells that are A? A is 1. Others, whatever may be, it is 0 because it is irrelevant for us. Now, what will be the reclassification? 1, 1, 1, 1, remaining the zeros. Agreed? Then come here, become 7. Other numbers may be zeros, negative. A is 1 and 7 is 1. So, sevens, what are they? 1, 1, 1, 1, 1. Remaining the zeros. Is it that? This can be applicable for a bigger one also. So, I have reclassified this, I have reclassified this. Now, finally, what is the thing? My cell should be, it may be 7 or it may be A. So, I have the answer, or I should be happy if I have A or 7. It need not do both. So, what I will do is I will have the addition. So, what will be coming? So, add 1 plus 0, 1 plus 1, 2, 0 plus 1, 1 plus 0, 1 plus 1, 1, 0, 0, and then 1. So, this is the, okay. Now, what is my question? What cells are A or 7? Maybe A or 7. So, these are all the things where my answer is whether A or 7 or both. So, these are all positives, no? All are 1. Remaining is negative, that is 0. So, now reclassify 1, 1, 1, 1, 1, 1, 1. These are zeros. This is logical OR. C programming you might have seen, no? Logical OR, logical AND. This is okay. Next. The similar one, what cells are both A and 7? Both the things are needed. So, same example. This reclassify 1, 1, 1, 1 zeros. Reclassify 1, 1, 1, 1, 1. So far so good. Until here same thing. Then my answer is what cells are both A and 7. So my answer should satisfy these two conditions, A and also 7. That particular cell should be having A and 7. So what I will go? I will go for multiplication. So here you can see 1 into 0, 1 into 1, 0 into 1, 1 into 0, 1 into 1, 0 into 1, similar. Now here what I will get is remaining one. So this is the area where I have both A and 7. Understood? Okay, that is logical and logical OR. A logical OR means it is summation, logical AND means multiplication. Okay. Now tell me, we have given few case studies. Landslide, flood, drought, then forest fire, earthquake. These are all disasters, right? Landslide I have shown you. What are the triggering factors? Landslide or groundwater potential zones. The landslide, heavy rainfall, more will be the severity or it is a triggering factor. Earthquake zone, there may be possibility of landslide. Soil is loose, there may be possibility. Okay, then what are the other things? Steep slope, there is a possibility. Is it not? Steep slope is a possibility. Then what is the best combination for landslide? Heavy rainfall, earthquake, steep slope, loose soil, less vegetation, because vegetation it will fix up but it will catch that soil. But low vegetation, like this, so many or any industrial or any anthropogenic activities. So slope is there and somebody is going to construct a road. It will be disturbed like this. You can have many factors. Geology, loose. Okay, you have sedimentary rocks in place of geology. If it is a hard granite, there is no problem. Like this. All this combination means what? Which we have to use? Logical or logical AND? Or AND? This should add up or anyone will be sufficient? Logical AND. Logical AND. Because all should combine. Logical OR means any one thing is there. Suppose if you have heavy rainfall, that will also cause landslide. If you have earthquake, obviously it will also cause. I am telling about the worst case. Like sir told already, a dam break analysis is there. What is the significance of this Dhanbad DBC corporation? Anyone of you? So in India we have got all the major multi-purpose projects where in the South India especially. So we will be storing the water and releasing the water slowly depending on operation policy. Highest priority is for drinking water, then for irrigation, hydropower, like that. Water will be released. Whereas this Damodar, it is called earlier called as a sorrow of Bengal. It is used for controlling the flood. Means June, July we expect heavy rainfall. Then what we will do is we will release all the water as per the literature I am telling, and we will have the store. Any excess water comes, it will be coming there, so that flooding will not happen. So upper Damodar we are having very less floods now. Only the lower Damodar, because of the land use changes, we are getting the floods. Okay, so that is one case. One dam failure you can accept, but in Italy, Professor is telling there are situations where 7 dams were failed. Rarest of rare incident. Isn't that? Okay. Let's go to solve this. So simple thing, just for understanding how it happens. Objective is identify an erosion prone area. What are the things? An area that satisfies the following criteria: has stable slope, has less soil depth, has less vegetation, has high intensity rainfall. These are the triggering factors. And the raster resolution is 100 meters, means the picture. Satellite imagery is a raster or not? Topo sheet is a raster or not? And the area is 0.5 by 0.5 kilometer. Now, first layer, that is slope. For your easy, I have not given any 4 or 5 categories. It may be steep slope, medium slope, lesser slope, flat, which is not like that. 1 represents steep slope, 2 represents low slope. Now, according to the first condition, okay, this is layer 1, layer 2, soil depth, lesser soil depth, it is 1, and then high, it is other values, 2, 3, 4 may be there. Vegetation, lesser vegetation is a triggering factor, whereas more vegetation. For simplicity, I have given 2. You can have 2, 3, 4, 5 like this, a bigger one. Rainfall, high rainfall 1, low rainfall 2. Let's go to the previous slide. Yes, what are the conditions? Steep slope, less soil depth, less vegetation, high intensity. All these things are given as number 1 in all the 4 for your understanding. Remaining are the other numbers. Next. So how I am going to analysis? Layer 1, layer 2. These 2 I will overlay first. Layer 3, layer 4 I will overlay. Then after that you will have 2 maps, steep slope and less soil depth, less vegetation, high rainfall. Finally these 2 I will overlap, you will get the erosion prone area. That is the simplest example for your understanding. Next. What I have to do? I have to reclassify now. 1 means steep slope. Other maybe other type of slopes. Steep slope is positive. So 1, 1, 1, 1, and the remaining are zeros. low vegetation, sorry, these two are directly, go to the previous, you can see this 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, remaining are zeros, is it right? Next, these are all solid, ones are there, remaining are zeros. Next. So here, what we are going to do? You are multiplying, is it not? You are multiplying. If you add, it will be 2 value will come. Okay, you are multiplying. Logical and it should have high steep slope and then high rainfall and then steep slope and low soil level. Next, yes, vegetation and then rainfall. So all ones are there, remaining are zeros. Heavy rainfall, all ones and then remaining are 0, and then you can multiply these ones zeros. Then what you will get? So that is the map. Now what is the last one? These two. You multiply these two. 1, 1, 1, zeros. Again 2 ones. The third one, that is 1, here it is 1 is there, but here it is 0. Obviously 0. You are multiplying. Okay, then remaining. Then here 2 ones. So 1, 1, 1, 1. Here also you get. But here what is happening? Zeros are there, but here ones are there. You multiply, you will get zeros. Finally, what is the area? This is the area. This is the area where you can have erosion. Simple one. So like this, can you do manually? It's not possible. That's why we are taking the help of the system. And you are writing the code, it will perform in seconds. You will be getting the map. So yesterday I was showing 10 layers. You can use 15 layers also. Immediately you will get the result. These are the areas. Okay. Whenever you are going for the worst combination, is it not? This is the flood prone area. And in that you can have the classification. Yes, next. So there are various operations are there. You can have various operations. Overlay is the next to this. These are all they going to have. Yes, next. Yes, this is the one I am telling. This is point buffer, external buffer, internal buffer, and line buffer. So the line buffer is useful for structural also. A road is there, all old city, and all the shops and then your buildings are there. You want to go for a single line to double line or double to 4 line. Then if you start doing your survey, obviously there will be some repulsion. Then what you will do, you will get the satellite data and then you mark the road and then you want to have the buffer. Is it right? Now it is width is 2 meters. You want to go for 4 meters. Then what happens? What are the structures that are being affected? You will get immediately, is it not? The buffer. So you can take the action. Similarly, this GIS is used for getting the land revenue because you can actually get the area. Yes. Close this.